Welcome to this video. S5, we'll be talking about function notation and a little bit of substitution as we use function notation. So yeah, the goal today is just basically able to function with this function notation. So as we kind of get started here, key reminder you can see here, f of x means the output of function f when the input is x. So our first question we're going to be asking ourselves on these questions is, do we have the input or do we have the output? If we have the input, the question is going to look like f of smiley face. We're gonna know what that x is. We're gonna know what that x is, and that's the input. Flip side is going to be if we have a question that says like, hey, f of x equals like sad face. That's an output, right? So they're saying, hey, we don't know what the input was, but we know what came out of this. So those questions kind of get solved different ways, right? So if we have the input, we're going to plug it in and probably simplify, get something out. If we have the output, it's going to be a little algebraic solve. So let's take a look at those questions. So our first one here is I do one. So we have some function. Let's just start with the function. So f of x equals some quadratic. Now in this question, in this video, we're talking a lot about polynomials, mainly quadratics. That doesn't have to be the case, right? So this function could be whatever. So this one just happens to be a nice polynomial. And this question says, all right, well, the input is -2, right? Because I can see this is just kind of sitting in that input slot, right? So I want you to put, it's basically saying I want you to put -2 in for x. So all we do here is we say, we can do that. So chuck -2 in for x. Everywhere I see an x. So, oh, that's not an x anymore. So that's a -2. So again, all I've done here is I've taken that input of -2 and I put it everywhere there was an input position. Now on the left, this is a placeholder, right? So this f of -2, -2 is just saying, hey, function f evaluated at an x, an input of -2. So on the right side, we're just going to clean that up. Well, so -2 squared is 4 times 3 is 12. Subtract 2 times -2, subtract -4, which is +4, +1. So we get an output of 17. So for an input of -2. Now notice the way I wrote that, I did not, on the left side, I know I have f -2. So kind of continue that like math is a conversation idea. I'm just going to kind of go down and I'm just going to put a like same. That's all this means is same on the left. So my final answer here is f of -2 is 17. And with function notation, that's a complete sentence. What this is saying is for an input of -2, for function f, I should say first, an input of -2 gives us an output of 17. Said another way, coordinate-wise, this thing would pass through the point -2, 17. Okay, so I'm going to get you to try one here, very, very similar. So yours is going to be a function g. Your input variable is t, but it's the same idea. So g of t equals -2t squared plus 5t. I'd like you to find g of -3. So pause the video, try this one, we'll come back for it. Okay, welcome back. So again, just kind of straight up, we can see, hey, on this question, our input was -3. I can see it's been filled in. So all we do is we take that given input value and replace every input position with it and then simplify. So you're going to get, at the end of the day, you're going to get g of -3 equals -33. And that's the final answer. Okay, let's change this up a little bit. Not too much though. I do too. So here we have another function h. So h, again, like the first one I did, will take x as an input variable. Now what we're going to do on this question is we don't actually know what the input is. What we're saying is, hey, the input is your original input plus 2. Now we're going to see in pre-cal 12, this is actually transformation. Don't worry about that for now. But all we're going to do is we're going to say, okay, well, no worries. Take that input and put it in the input position. So the input now becomes x plus 2. So the 2 times the input squared minus 3 times the input. And then again, I'm just going to simplify that. So on the left, I know whatever, it's just the same, h of x plus 2. On the right, I'm just going to evaluate. So x plus 2 squared, don't forget the middle term, that 4x Over here, don't forget to distribute the negative to both pieces, negative 3x minus 6, and then clean it up. So 2x squared plus 8x plus 8 minus 3x minus 6, and then one more step here. So this is going to be my last step, so I'm going to come back for the answer. So what I'm telling you about is h of x plus 2, and that's going to be equal to 2x squared, 8x minus 3x is 5x, 8 minus 6 is positive 2. So what this says is, okay, our function h evaluated with some input x plus 2 just returns 2x squared plus 5x plus 2. So in a similar vein, I'm going to get you to try one of these. I've got one right here. So here's yours. So if p of x, again, a different function, if function p is x squared minus 4x plus 1, I'd like you to find p of x minus 1. So pause the video, take a shot at that one, and then we'll come back for the answer. Okay, so here you go. So again, you can just see same idea as last time. So I have an input of x minus 1. I'm just going to pop that in for the input positions and simplify to get the final answer. Last one, changing the game a little bit again. So this question says, hey, f of x is 2x minus 5. Solve f of x equals 9. So notice the difference here. So this is, we don't know what x is. We have no idea what the input is, but we know the output is 9. So if we know the output is 9, just kind of follow the structure, right? So this is telling me, let's change colors. This is telling me f of x is 9. So if f of x equals 2x minus 5, f of x is 9. So just pop the 9 in for f. So 9 equals 2x minus 5. So this is again saying, hey, what x would have given me an output of 9? So if I isolate x here, I'm going to add 5 to both sides. 2x equals 14. Divide by 2, x equals 7. So that is our answer. Now notice function notation-wise, we don't love that. Up here, we had a really nice, like, hey, if your input is x minus 1, your output is this. Down here, we're now just kind of generically saying, hey, x is 7. When is x 7? And you have to look back at the question for if the output was 9. So if we wanted, as a complete sentence, we don't have to here. But what this is saying is, hey, really f of 7 was 9. So this is a full sentence. It's saying, hey, an input of 7 produced the output of 9. You could check that in the original function, right? Because if you put in 7 here, you're going to get 2 times 7. 14 minus 5 is 9. Done. But again, you don't need to write any of that stuff in green, but that is the context. Okay, one more for you to try here. So your last question is you do 3. So p of x, repeat that, p is x squared minus 4x plus 1. If we know p of x is 1, solve. Pause the video, try that question. Okay, we're back. So here you can see, just like last time, we know p of x is 1. That's an output. So an output is 1. So we are going to put 1 in the output spot, not the input spot, and then we solve back for the input. So from there, I get a quadratic. I get x is 0, x is 4. So either of those inputs would have given you that output of 1. And that's it. So do like the big trap, and I'll just write it here, is the output is 1, not the input, right? So the most common mistake here is going to be just you get a number, put in for x, and then go for it. You really have to be able to recognize, is that an input and output that I'm given? Okay. So wrapping this one up, a little final checklist for you as you do function questions. So first, again, do you have an input? Do you have an output? Very different solution strategies. If it's an input, make sure you're using brackets, parentheses. Substitute for every position, right? So everywhere that input variable is, it's getting replaced with whatever your input is. And then if you have an input, you're simplifying. If you have an output, it's just going to be a solution question. So pop in the output value and then go solve it. And then you can always check in the original function. I often won't, especially if it's a polynomial, there's no domain problems. But feel free, if there's any doubts, check it, or if it's some other more advanced function, check it. No worries. And that's it. Thanks for watching.